So FCX day 25. On day 25, we will be learning and talking about transport layer security, TLS or SSL. Important topic. TLS stands for Transport Layer Security and Secure Socket Layer. In yesterday's lecture, we have talked about IPsec. Today we will be talking about TLS. TLS is basically a cryptographic protocol. Okay. Which is designed to provide communication security over the computer network. It's being widely used in the world of email, IM, instant messaging, voice over IP, but it is predominantly being used in order to secure HTTPS, mostly over the public visibility. It is responsible for the three network goals that we have: confidentiality. How to achieve confidentiality? By doing the encryption. It supports the next generation cryptographic algorithms, encryption algorithms. Integrity and authenticity with the help of hashing algorithms, which we do have it. And authenticity with the help of the digital certificates. So TLS provides CIA for the traffic which is moving over the public internet. If we talk about the history and all, earlier TLS is used to call as SSL. Netscape is the name of the company. It is the one which has developed the original SSL. And the name of the engineer used to call as Tahir El-Gamal. Okay, Tahir El-Gamal. These also used to call as father of SSL. So if you talk about the journey, the first version was SSL 1.0. It was never published. It was for the Netscape company only. So it was unpublished. And what is the status also? Unpublished right now into the market. When you talk about SSL 2.0, it came into the market in the year 1995. And it has been deprecated, gone from the market in 2011. The later version came is SSL 3.0, released in the year 1996. It has also been deprecated from the market in the year 2015. Post, instead of creating SSL 4.0, they have given the nomenclature called as TLS 1.0. You won't believe it. It has been introduced in the world in year 1999, but it has also been deprecated in the year 2019. No, it is being deprecated in the year 2021. Just in a span of 3 to 4 years, this protocol becomes such a huge hit. Say, for example, in the year 2024, still you will be using the word SSL over TLS. So whenever out of 10, if you ask what is HTTPS, S stands for, they will say SSL only. Out of 10, 6 to 7 to say SSL rather than TLS. But actually this S representing in today's world is TLS, because SSL is deprecated. The last which is being uh, issued was in the year 1996. TLS has introduced into the world 1999. Post that, TLS 1.1 came into the picture. It has been given in the year 2006. It has also deprecated in the same year during our pandemic times. Later, into the stage, the two TLS came into the market, TLS 1.2, that has been introduced to the us in year 2008. In use, still in use, it's being used by the browsers. And the last version is DLS 1.3 that has been introduced in the year 2018, and it is also in use. The RFC which is being written, request for comments, in which the TLS 1.2 is being written, is the famous 5246. And the RFC which is written for 1.3 is 8446. These are the requests for comments in which these protocols has been highly defined. Okay. The support of TLS 1.3, which is the latest one, MD5 support has been revoked. MD5 support is not there. One of the important portion which has been done. Cha-Cha 20 has been added. The latest one with Poly 1305. The bottom line is, whatever the versions are getting changed, meaning is the cryptographic, as I written it, it's a cryptographic protocol suite in which the version change means the addition of new next generation cryptographic algorithms has been added. The old ones has been deprecated because they used to support old kind of cryptographic algorithms. Okay. Next. When you talk about SSL, the handshake is important to understand. I'll take quick brief to explain this. Say, for example, this is my client and this is my server. Between them, the SSL/TLS handshake is going to happen is the first thing that the client is going to do towards the server is send the client hello. The name of the message is called as client hello message. The client hello message carries 5 important fields. What are the 5 important fields we do have? A. It is going to use a random number, which we call as RNC, random number. You will always see an RNC is being. Why C? Because it's a client who is sending, so C stands for client. It's a 32 byte. In this, actually 28 byte is the random number, and 4 byte is the combination of day, date, and time of the client machine. Second, the TLS version goes into that. Like in IPsec, it sends the IKE version, IKE v1 or IKE v2. In a very similar way, the TLS version will be sent in this particular case. A moment back, I told you that 2 versions are running in today's world. Either it will be 1.2 or 1.3. So TLS version 1.2 and 1.3. Banking sites. They don't compromise on the version. So if in today's world, if your Google Chrome or Mozilla Firefox, if it is not being updated and you try to reach any of the banks and your browsers are using 1.2, you will see that the 404 error coming on your page. Banks will not compromise on that. The server will say that we need 1.3 version only. If you don't have it, update your browsers in order to take our web servers. Third, compression method. In good old days, there used to be a compression methods like when you used to have 512 kbps, right? I hope everyone knows zip and all, right? We used to send certain data, we zip the files, we compress the file, same way. Same way. The TLS protocol also can compress the messages and send it across to the servers. Whenever you are using Wi-Fi and all, and you have a good bandwidth, this compression method doesn't come into the picture. But yes, when you have a less bandwidth and you are browsing your particular browser, the client automatically choose the compression method and compress the messages and send it across to the web servers. Fourth, the session ID. If the client is trying to reach to the server, if client is trying to reach to the server for the first time, the session ID will always be 0 or null. And in return, when the second message we will start learning, in return, the server is going to provide a session ID to the client. Fifth, when you talk about the TLS, the most important concept comes over there here is cipher suite. Here it sends the combinations of cryptographic algorithms. Whatever the client browser supports, whatever the client supports, browser supports, it sends it towards the server. That I support this so and so. Say for example, I'll show it to you. Give me a sec. So when you talk about the fifth one, if you see it over here, I'll clear the screen for us. The client hello, which is going to be sent, you see that the TLS version sends. There is a random number. When the session ID is 0, that means it is client is trying to reach to the server for the first time, and 79 different combinations. You see this? 79, or in this particular case, 17 different suites are there. Protocol suite. TLS elliptical curve Diffie-Hellman, elliptical curve DSA with AES 128 and this. And if you see it over here, it is clearly written. What is this combination of algorithms? What is this combination of algorithms? TLS. One of the algorithm is being used for the key exchange over the public platform. And we all know the best one to use is the Diffie-Hellman. So Diffie-Hellman is a key exchange algorithm. The next one is being used for the authentication. Digital certificates. And we know that the digital certificate, whenever is coming into the picture, it's all about public and private keys. So you have RSA or you have DSA, two algorithms you have. And then for the data plane, it's always a symmetrical encryption algorithm, AES, always. I always used to tell that data plane bulk encryption can never be done with the asymmetric algorithms. Asymmetric algorithm meaning RSA, DSA, these are asymmetric algorithms. Symmetrical algorithm means AES, DES, 3DES, and so on and so forth. Data plane will be always encapsulated by symmetrical algorithms. And in the last, for the authenticity, you have the hash. I hope till now it's clear. Okay. Next. So cipher suites get into this particular option. So first message is client hello, which carries the 5 things. And I've told you what are those. In return, the server is going to send a message which we call as server hello. In the server hello, the session ID will be filled up. You will see the session IDs. Some session ID, the server is going to 1, 2, 3, 4, 5. It will agreed upon the TLS version. It will agreed upon the compression. And one of the cipher suite that you have sent it, one of the cipher combination will be selected from that suite. Which one will be selected? Which one among the 17 or 70 different combination the server is going to choose? So at the time of making this server as a web server, okay, the administrator of this particular web server will tell its preferences. First preference is this, second, third, fourth, fifth, and sixth, and so on and so forth. So if I can show you somewhere. There you go. You see that? I think this. While creating, this is on Windows, okay? Windows Server. While creating it, you choose it, enable it. Your options are in the cipher suite. You choose that. Which algorithm is going, and this will be selected in top to end orders. I'll show you another one. This is one option. See this? These are the ones which, why it is blur. Should not be blur. I mean to say here, say for example, SSL cipher suite order. You see that? Order. Enable. You choose it. Which one should be the order of the cipher suite? So the client is going to give you the option. The server will have the options. You being an administrator can manipulate this particular or change this particular order. It's up to you. So it is up to the server's administrator, like an agreement between them, sir. It's the server's administrator which is going to, while configuring the web server, does this thing. Next. Once the server hello has been sent, then it's the responsibility of the server to send server certificate. What is going to be sent? Server certificate. In the server certificate, digital certificate, which we talk about it, the public key will be indulged. Public key of the server will be involved. So client right now, in the server hello, the RNS will also be sent. RNC has been sent from here. It's like how I can explain this to you in the world of IPsec. When we took the lecture, you remember SPI of the initiator, we also used to call this as cookie, and SPI of the responder also called as cookie for the responder. It's in a very similar way in the world of TLS, we call this as random numbers, RNC for the servers, RNC for the clients. So by now, this particular message, client is having its own RNC number. Client now in the second message received the RNS, which is random number by the servers. Along with that, it also carry now the digital certificate in which the public key of the server is involved. And the server is also going to demand. Server demands the client certificate, and this is called as phase one. This is phase one of the TLS handshake. Demands the client certificate, and phase one is being done. The moment the client receives the server certificate, it's the responsibility of the client to do the verification of this server certificate. How to verify it? Because in the digital certificate, you will see that who is the issuer. That issuer portion will be sent it across. Issuer will be sent it across. Okay. Now, because the server has demanded the client certificate, it's the responsibility of the client. Client sends its certificate to the server. So client sends its certificate to the server. So client sends its certificate to the server. It sends. Now what's next? Now the client is going to generate a key. The name of the key is called as pre-master secret key. Which certificate client sends? The client, when you go into that, it has its own personal, what do you call that? Certificate which is being present over there. The personal certificate which is being present over there is being sent by the client. If you so go into the MMC control server, the client has its own digital certificate which is being present. That certificate client is going to send towards the server. One is trusted authority, one is personal certificate that will be sent. And now the client is going to generate a key which we call as pre-master secret key. This is called as pre-master secret key. Point to be noted, PMS will be created by client only. Server never creates it. This is a pre-master secret key which is being created by the client, and it is sent towards the server. And followed by this, both with the help of this pre-master secret key, PMS, both is having it, right? They have their own RNC numbers, RNS number, random numbers are there, plus the def element public keys, multiple things are there. They collectively gonna create a master secret key. And this master secret key will be used by the bulk encryption, algorithm. Windows does it, a software, the system does it. The system means the Windows only does it for us. Okay. Just to correlate this, sir, both of you knows in the world of IPsec, we have discussed, we have session key ID. In IPsec, we have _D, _A, _E, right? _E is being used by the control plane, IKE. _E is used by the ESP protocol, right? In today's world, A moment back, you have seen that, and I've shown you earlier, right over here. When you talk about the cipher suite, that combinations, this, right? So if you see it over here, one is called as encryption algorithm for the key exchange, right? One is for your digital certificate. One is for your signatures, which is having the digital certificate signatures are there for the authentication. So this is being used for authentication. This is being used to exchange the key over the public internet. And this algorithm is required. So I have told you that how to do encryption. In the world of encryption, you need two things. You need an algorithm and you need a key. So the key which will be used by the TLS protocol in order to encrypt is nothing but the master secret key and the algorithm which we have chosen in the cipher suite. Okay. So this master secret key, which is being generated by both the devices, will be used by the bulk encryption algorithm, which say, for example, in case is AES. And in the last, once the key is being generated, then let's start the proceedings. Let's start the process. Let's start the data plane. So this is like your TLS or SSL handshake, which we got to know. Now, once you got an idea about it, let's start with SSL VPN on the FortiGate infrastructure. When you talk about the SSL VPN, okay, this is basically being used in order to have remote access VPNs generally. So SSL VPNs are predominantly being used for the remote access VPN. That means one end is your networking device and another end is your client machines. Like IPsec are predominantly being used when you're both the ends, you have networking devices like site-to-site VPN, right? Like we have seen in yesterday's lecture. But if one end you have a networking device and other end you have a client which is being present over there, right? And the VPN that you want to approve, this is called as remote access VPNs, RAVPNs. And TLS or SSLs are predominantly being used in this particular cases only. VPN deployment modes. Let's talk about it. When you talk about this VPN, there are two modes you can use to access the SSL VPN. Tunnel mode or web mode. Your choice. Both can build an SSL VPN connection, but their features are different. Which one should you use? It depends on which application you need to send through the VPN. Okay. So the technical knowledge of your users and whether you have an administrative permissions on their computers, accordingly, you can choose that. Comparatively, tunnel mode basically supports majority of the protocols, but requires a concept of VPN client on the end machines. Or more options, it requires a virtual adapter to be installed. It requires a virtual adapter to be installed on the machine. So to tunnel traffic using this virtual adapter, you must use the FortiClient remote access feature or the FortiClient VPN only. Web mode is basically your web browsers. If you want to compare this, web VPN, the same thing versus AnyConnect in Cisco's platform. AnyConnect is basically a Java-based application which needs to be installed on the client machine. And web VPN are going to use the browsers. But the support is limited. FTP, HTTP, HTTPS, RDP, Common Internet File Sharing System, SSH, Telnet, VNC, and pings. And whereas your tunnel mode supports almost every protocol. but it requires a Java-based application. So tunnel mode is nothing but any connect in Cisco's world. Let's start with first web mode. The web mode is the simplest among the all. Web mode is the one which is also called as SSL mode or web VPN. Like you would like any other HTTPS website, you simply log in into the SSL VPN. You will get a portal page. You will get a portal page. On the top, you will see the name with which you have logged in. And on that particular portal page, you will see the bookmarks. You will get a server access, access point consoles, FortiGate consoles, Salesforce servers, invoices. What you will be able to access. It acts like a server-side proxy, reverse proxy. A simple, secure HTTP and HTTPS gateways for us. The bookmark is basically the section on the page which contains the links to all or some of the resources available for the end user who is logged in. Say, for example, in this case is the student. You can also have a quick connection at the bottom. You see that quick connection? It's a widget which allows user to type the URL if you are not seeing it in the bookmark page. The web VPN has two main disadvantages. All interaction with the internal network must exclusively be done by the browsers. External network applications running on the user PCs cannot send the data across the VPNs. Next. This supports limited number of the protocols, which I was stating a bit earlier also. So when you talk about web mode, you can have the bookmarks, you can have the quick connection. If it is not being here, you can add your own bookmarks also. It uses the browser in order to connect it. So how does the web mode works? The remote users, RAVPN users, establish a secure connection between the SSL security in the web browsers and the FortiGate firewall portal page, which is going to provide it. Once being connected, the user provides their credentials in order to pass the authentication. Then Fortinet displays, this is the portal page. It is going to display the SSL VPN portal and contains the services in the bookmark world. Or if it is not being there, you can see the quick connection. You can do that. Tunnel mode. Tunnel mode is the second option for the Fortinet and provides the access to the resources within the VPN. It requires a Forti client, as I mentioned it earlier, to connect the Fortinet firewall. That means a Java-based application is required. A FortiConnect clients basically like comparison, AnyConnect. When you install a AnyConnect on a machine, there will be a virtual adapter which will be installed along with the physical one. In a very similar way, in the mode tunnel, when you have a Forti client software, a virtual adapter will be installed. And this virtual adapter will be referred and will be seen as Forti SSL adapter, virtual adapter. It will be identified by this. This virtual adapter will be getting an IP address from the FortiGate firewall. Like IP pool, you can create it. And from that particular pool, this virtual adapter will get one IP dynamically. Inside the tunnel, which is being created with the virtual adapter and the FortiGate firewall, Everything will be encapsulated, encrypted, and CIA will be achieved by that. Confidentiality, integrity, and authenticity. The main advantage of the tunnel mode over the web mode is that after the VPN is established, any IP network application running on the client can send the traffic. That means it supports 99.99% different types of protocols. You can say that this protocol doesn't support it, but it can support. But still, I have, instead of writing 100%, I've written 99.99% traffic can be used for that. The main disadvantage is that the tunnel mode requires the installation every time. A Java-based application is required, and which requires this particular, in order to install this particular software on the machine, you require the administrative privileges. The privileges comes into the picture quite handy. So how the things works in the mode tunnel? The user connects to the Fortinet firewall through the software which we call as FortiClient. User page will come where it provides his credentials to successfully authenticate. The virtual adapter, which is being seen as FortiSSL, this FortiSSL. The FortiGate establishes the tunnel and assigns an IP address to this virtual adapter. Virtual adapter creates the tunnel. This is the client source IP for the duration of the connection until it's being intactful. Then the users access through the encrypted TLS or SSL tunnel. The FortiGate firewall receives the encrypted traffic. It de-encapsulates those IP packets and then forward it to the network which is behind this particular Fortinet. So this will be, say, for example, WAN interface. This was our LAN interface. That's how it works. Next. The Fortinet can be configured as a SSL VPN client. They can configure as a VPN client using the SSL VPN tunnel interface type. Use SSL VPN tunnel interface type. When an SSL VPN client connection is being established between the client and this Fortinet firewall, say, for example, this connection has been established, the client dynamically, this is important, add a route. Like in any connect, the route is used to be add, right? To the subnet that is written by the VPN server. So a device connect to the Fortinet firewall can access the resource behind the server Fortinet. How? Because it adds the route. Tunnel established between the two Fortinet devices, you can do that. It can go with the hub and spoke. Client Fortinet dynamically add the routes to the remote subnet. Assigns a virtual IP to the client, which I already told. Advantage. Any IP network applications on the user machines connect to this can send the traffic through this tunnel. As I mentioned, 99.99% traffic can be supported by this. It's useful to avoid the issues caused by the intermediate devices such as ESP packets being blocked somewhere. Some devices does not support. Policies has to be created. Some of the places you might see that the UDP port number 500 or 4500 in yesterday's lecture, we discussed about NAT traversal. Fragments being dropped, causing IKE negotiation that uses the large certificates to fail in the peer, does not support the IKE fragmentations. But what is the problem? It requires the proper CA certificate because TLS is coming into the picture. Certificate is very important in this particular game. TLS means SSL means certificates. And that we're going to talk about this over the period of time. Next. The meaning of this particular page is to make Fortinet firewall as a client. Not a Windows machine where you are going to join the or install the Fortinet client software. You understood? Imagine, just to give you a correlation, you have two FTD or ASA firewalls, just to correlate it. Okay. And you want to have a VPN. So this will act as a client. This ASA you can act as a client. That is called as Fortinet as a client. Connect to the server Fortinet device as a SSL VPN client. So this particular one of the Fortinet firewall, I'll show you in the next slide. You see it over here. Both are firewall, but one is acting as a client. One of the Fortinet branch office is going to act as a Fortinet client, and your headquarter, you can act as a VPN. So client Fortinet connects to the server Fortinet server over the TLS. SSL VPN client Fortinet uses the pre-shared key, local user account, or the PKI's client to authenticate. The virtual SSL tunnel interface creates the tunnel's IP address assigned from the SSL VPN server. From here to here, the IP will be released. Route is being added to the client to access this. From here, the routes will be added to access these remote servers on this port number 2. The user devices accesses resources through an encrypted tunnel, which we call as SSL or TLS down the line. Next comes a very important concept, which we have also seen earlier. And again, you can correlate this with any connect. The next slide, split tunneling. So tunnel mode only supports the split tunneling. When the split tunneling is disabled, all the IP traffic generated by the client computers, all traffic, including the internet or including the data which is behind this particular servers or in the demilitarized zone, is routed across or through the VPN. Tunnel all, by default option, tunnel all. So when split tunneling is disabled, all the traffic routes through the SSL VPN tunnel to the Fortinet firewall and then to the destination that includes the internet traffic. An egress firewall policy is required because the traffic is going, say for example, this particular user wants to reach to the google.com. So the traffic first goes to the tunnel, reaches to the Fortinet firewall, and this is called as your hairpin traffic. In firewall, ASA firewall, intra-interface command, same security level, intra-interface. So with this, when the tunnel mode split tunneling is disabled, the traffic inspection and the security features can be applied. Why? Because all the traffic from the end user is coming to the Fortinet firewall where the logs can be generated, inspection can be done, and furthermore actions can be done. If the split tunneling mode is enabled, only the traffic which you will tell to go into this particular, whatever the interesting traffic you wanted to go, only that will go from this client. For you reach to the YouTube, Google, Instagram, and all this can go in a different separate way altogether. All other traffic is sent through the usual unencrypted route and there is no traffic inspection. This is the disadvantage. If you enable the tunnel mode, there is no inspection of the traffic because the FortiGate firewall does not have any idea or clue about it. But if you disable it, the traffic goes, all the traffic goes from this. This is where the hairpin traffic starts. And that's the important game. When you enable the split tunneling, it helps to conserve the bandwidth. The important point is also this: conserve bandwidth and elevates any kind of the bottlenecks that's being done. So it's your choice, it's your call whether you want to enable it. It's a user perspective. I have seen both as being deployed, disabled also, enabled also. Disabled, why? Because they want to do the inspection of all the traffic which is going from your laptop being a company's employee. And there are people who just wanted to disable it. That means only traffic which needs to be sent towards the company's premises needs to be sent through this particular tunnel. Rest all the traffic can directly reach to the segments directly. It's their call. Next, the knowledge check. A web mode SSL VPN user connects to the remote web server. What is the source IP address? The Fortinet device sends an internal IP address. We have discussed this. Which statement above the tunnel mode SSL VPN is correct? It supports split tunneling. Previous slide only. A web mode SSL VPN user uses dash to access the internal bookmarks. And if the bookmarks are not available, you can have a widget at the bottom. You can directly write the URLs for the same. This is SSL VPN deployment modes. Configuring the SSL VPN. Quite very simple. To configure the SSL VPN, you need to take a decisive steps. Step number one, first you need to have the users, SSL VPN users, like you are creating the users local to the Fortinet firewalls. Configure the SSL VPN portal page. Configure SSL VPN portal page. Third, configure the SSL VPN settings. Fourth, create the firewall policy to and from the SSL VPN interface. And fifth is an optional where you can configure a firewall policy to allow the traffic from the SSL VPN client to the internet and apply the security profiles on top of that. Over the period of time, I'll keep on applying and explaining that. Point number one over here, when you have this set up the user accounts and the groups you can have your Forti authenticator. You can use FSSO, which is called as Fortinet Single Sign-On Protocol, to do the authentication using an LDAP servers or Radius, and that over the period of time we will see that. Because we have not discussed this as of now, I am going to do and use the users in the Fortinet firewall only. We're going to do that. Next is step number 2 is configuring the SSL VPN portal. This is the portal page, how it looks like. The SSL portal page contains basically the tools and the resources link for the users to access. Tunnel access, you see that portal page. Tunnel mode, web mode, tunneling, split tunneling. SSL VPN portal determines the access profiles. In the tunnel mode, when you enable the split tunneling, in the tunnel mode, you see that split tunneling option is there, because web mode does not give you that. In the tunnel mode, you have a concept of split tunneling. Okay. So in the tunnel mode, when you enable the split tunneling, you need to select either enable based on the policy destination, or you can choose another option called as enable for the trusted destination settings, which generally and usually specifies the network behind the Fortinet firewall. Enable based on the policy destination, this option allows the client traffic in which the destination is matched with the destination configured on the firewall policy. So whatever the firewall policy, as I said it earlier, the fourth step, right? The fourth step, policies, whatever the policy you create, and in that, whatever the destination you have chosen, that is going to be used. Enable based on the policy destination. Firewall policy, whatever the destination is there, that traffic will be allowed in this. Enable for trusted destination, the second, allows the client traffic that does not match the policies which you have created in the destination segment. So this in any connect is tunnel all is one option. That means split tunneling is disabled. In any connect, I am trying to explain. If tunnel all option is there in the any connect ASDM, that means that is called as disabled. In Fortinet, we call that as that. In ASA, we have tunnel all. Network list below. List below. That means whatever you have defined in the ACLs, that option over here is called as enable. That option is called as enable based on policy destination, and network exclude list below. That is basically your enabled for trusted destination. Why I'm explaining this? Because you guys have done ASA with us. So you can correlate this particular segment. Also, when you're talking about the tunnel mode, because a virtual adapter is going to be there, you are supposed to create an IP pool address. That virtual adapter will get an IP from this particular pool. So there is a default pool available within the address object. If you don't want to create it, there is a default pool, or you can create your own, which you can see that. Once you enable the web mode, you have a web mode. You can customize the SSL VPN portal page. It's your call. You can check the bookmarks. You can add your own bookmarks. You can see that to appear for all the users who is then in the SSL VPN portal page, and so on and so forth. So this is the point number 2. Because the point number 1 is user authentication. Point number 2 is SSL VPN portal. The third point is SSL VPN settings. There you go. So after you configure the portal page, the next step is the VPN setting page. Let's start with the connection setting, which is on the top. Here you need to map a Fortinet interface to the SSL, which interface over which the VPN is going to be get terminated. The default port number for the SSL VPN is 443. In order you wanted to change it, you can change it to some random port number 10443, your choice. In that particular case, when you are talking about the web VPN, the URL that you are going to write is https://10.200.1.1:10443. Why we need to change the port number? Is security reasons. Okay. This means that the user needs to connect the IP with this particular URL. And in the last, it should be separated by 10443. As port 443 is the standard port numbers. Next, restrict allow access to the known host. Allow access for only the hosts which are, excuse me. Yeah. Allow the access to those particular hosts which are being known. That's a good options. The inactivity is basically your 300 seconds, 5 minutes, the default one. Can change it to 3000 seconds, your choice. Finally, like any other HTTPS websites, the SSL VPN portal presents a digital certificate when user connects. So certificate is also, so require client certificate. You remember I started today's lecture like this. Client sends, it's client hello, right? Server sends, server hello. Server sends is digital certificate. Server demands the client certificate. That was the 4th line I have written it. Client certificate. This option you enable, it requires the client certificate. Okay. Next. Tunnel mode client settings automatically assign. You see that define the IP range for the SSL VPN. You can do this with the CLI also. You can do this with the GUI also. Your choice, your call. Resolves the names by the DNS servers. Indeed, you can add those particular things. Use the internal DNS if you are trying to reach to a particular server who needs to be get access via FQDN, fully qualified domain name. Another option is whenever you are trying to create IP pool, the IPs are assigned to the client virtual adapter while joining to the VPN. The IP allocation has 2 methods. First available or second option is round robin. The default method is whatever the IP available next in the pool will be given to the end users. Otherwise, round robin also can be used. And DNS server, The resolution is effective only when the DNS traffic is sent over the VPN tunnel. If you have not sending the DNS traffic over the default tunnel, then it has of no use. Finally, you can use different users also. You can see that all other user groups, add a user groups. You can allow different groups of the user to access different portals. In this example on this slide, teachers have actually, you can see that the access to this particular things on the web portals. Accountants can have a different portal page and so on and so forth. Next, the fourth option is basically the firewall policies. SSL VPN, you're going to create a policy, incoming interface, outgoing interface on which the VPN is going to be get terminated. What are the source? Accountant, teachers. This is what I was talking about. Accept. These are for the one which will be used in order to create the VPNs. Okay, the policies which is required. And done. And this is for the theory of SSL VPN that we have done it. So web client VPN, yes. Okay. Today's lecture is cleared, sir. Satish, sir.